JavaScript Obfuscation, it's all about the packer. A few words about myself. My name is Katz. I'm former OSP Israel chapter lead. I'm data-driven security researcher, which means data plays a significant role in my day-to-day research, and some of the work that I'm doing is driven by data. When I try to define my role, I'm saying that I'm trying to move security challenges into the science and solution space. And I think this research and the story behind the research tell a story that comply with that kind of notion. And last and definitely not least, I have a boring social network persona. Therefore, I don't encourage you in any other way or any given way to follow me on Twitter on _Katz. Please don't do that. As I was saying, boring. Let's get started. So how did I end up here, right? Over a year ago, I was doing some research about JavaScript obfuscation. And during and as a result of that research, I published 3 different blogs to try to describe different elements or aspects of JavaScript obfuscation. I was going over some of the techniques being used in the wild and trying to create a dictionary-based kind of notion for that. I was going on a specific example and taking that example and breaking that to very small pieces and trying to follow those kind of code and try to figure out what really happens out there, which is the image that you see in front of you. And the last one was I tried to show some trends on JavaScript obfuscation being used on phishing websites. And when I was doing that, and that's the interesting part, and as you can see in the image in front of you, when you look on obfuscated JavaScript code, it's really hard to understand what really happens here. And it's a bit challenging to do that. It's not impossible. It's not something that is, cannot be done. But once you go over those examples and try to do some deobfuscation and debugging for that, you will have some challenges and definitely don't have skill in the context of creating the ability to identify a mass amount of files or pages that are using JavaScript obfuscation. So that's initiated my project, and these are the 4 objectives that I had once I started this research project. So the first objective was to try to figure out if I can find a technique that will enable me to do detection for obfuscated JavaScript, and preferably doing that for a malicious obfuscated JavaScript. And we'll spend significant amount of time to talk about, why I'm mentioning malicious, right? Why JavaScript obfuscation is not malicious by default. The second objective was to do that at scale, as I mentioned. It's not about doing 5, 10, or 20 kind of those files per, a given time frame, hour, a day, whatever. It's about the scale. It's about doing that on huge amount of files and doing that really quickly. And that's the third element here, which was my choice to use a static analysis technique for doing that. I don't want to be able to render those pages that I suspect that are using JavaScript obfuscation. That's part of my limitation. I need to do that on the actual file that's being sent without being able to render that file. And some of the reasons behind that are related to performance, and this is some of my objectives in that context. And the last objective, which is an important one, was that my assumption of Pareto principle, which means, in other words, I'm not here into detecting any kind or any version or a variation of the ability to use JavaScript obfuscation. It's about trying to use our ability to map the most used, the most popular JavaScript package. JavaScript package are the software that being used to obfuscate a given JavaScript code, using the ability to detect those packers, and by detecting them, eliminated 80% of the problem of JavaScript obfuscation being used in the wild. Because those packers, the most used one, create the most value in the context of detection. And that was one of the objectives that I had in mind. And here are some links to the research that I was doing over a year ago. So when I started this project, I had a few questions. So the first question that comes to mind was, hey, how, or in other words, why and how JavaScript is being obfuscated? So what are the reasons for that? And we'll try to address that. What are the numbers behind the use of JavaScript obfuscation in the wild? So, right, I chose some project, but is it valuable? Do we see a lot of those numbers out there? Do we see these techniques being used in the wild? And what are the numbers behind that? And that was a really important thing for me to address. the third question was, is it possible to detect obfuscated JavaScript, right? And right, this is why we are here today, and me trying to figure out if we can do that or not as part of my research. And last, and I touched that, and I will continue to address that. What does it mean, obfuscation? Does it mean malicious? When we see something obfuscated, that's directly indicate that something is malicious? Well, the intuitive answer is that it's no, but we will address that in more details. So let's get started from the beginning. Why JavaScript being obfuscated? So JavaScript is a client-side scripting language running in most cases on our browsers. And once we have a code that runs on our browser, we actually have the code, so we can actually understand the logic and the steps that happens once that code is being executed. It's really simple. So in other words, if someone want to make sure that the code that runs on our browser is not well understood, right? It's really hard to understand that code, or it's really hard to debug that code. That's the reason why we'll do obfuscation. And in a sense, right, as I mentioned before, it's not impossible to do deobfuscation for a code. So it's a security by obscurity, right? It's making our ability to understand that code that runs on our browser much harder. So that's the incentive for someone to use that. But there is another incentive for that, which is in the relationship between defenders and threat actors, right? We have abilities to detect those kind of malicious files that are being sent to our browser or to our computer. And some of those techniques being used are hash-based or text-based detection techniques. And once you use an obfuscate to obfuscate the code that you send to the clients, that means that from a detection point of view, it's much harder to detect that by text or hash-based detection. And that's one of the incentives for some threat actor to use those techniques to make our life much harder, and in a way to try to evade detection from an adversary point of view. Now, there is a different translation for that, and that's something in my mind of the relationship between defender and adversaries, right? So from a defensive point of view, when you need more resources, right? When you need more resources to go over some files and try to figure out what really happens on those files because they were obfuscated, that might result with more time. And once those two conditions are met, the chances are that you will have lower detection because you need to work harder to do that. Whether you're doing that manually, right, as I was doing at the beginning, or whether if you are doing that automatically, it will require more processing time to do that. And from an adversary point of view, most chances that they will see higher success rates, which means more revenue, more money, more damage that they can create. And that equation is something that, in my mind, explains a lot of the things that we see out there, a lot of the trends, right? Regardless of obfuscation, a lot of the trends that we see out there are derived from that equation. So we talked about the why. Let's talk about the how, right? So how JavaScript is being obfuscated. So one way to do it is to create a repetitive, meaningless functional var names, right? You create a code that contains a lot of those things, and when you look into that code, it's really, really hard to understand what's the meaning of the code, what's the context of being executed, because there is a repetitiveness, because there is meaningless kind of function and var names that are really not readable, and therefore it's really hard to understand that. Another way to do that is to use anti-debugging code techniques, meaning once you want to try to understand that code, when you want to try to go over that code and do debugging for that code, you will have some problem in doing that, right? It's not impossible, but it will make your life much harder. And the last element, right, and these are three really generic kind of notions of how JavaScript is being obfuscated. Consuming more computing resources or time, and in other words, for example, introducing dead code or timers into the JavaScript that you're using will at the end of the day create much more processing time or much more debugging time, and as a result of that, time is a factor for detection, and as a result of that, they might have a greater success rate in the context of things will not be detected on time. So we talked about the why, we talked about the how. Now let's get to practice, right? So over a year ago, I was doing my research, and as part of my research, I was able to see 4 different samples. These are snapshots from 4 different files that I was able to see that were obfuscated, JavaScript files that were obfuscated. And when I, at the beginning, look into those files and into those snapshots from those files, I was saying, hey, they are definitely not the same. But when I tried to zoom out, I was saying, hey, there's something here, I'm not sure about it, but wait. Before saying that there is something that might be similar between them, I can tell you they are not the same. Different file. Why do I know that they are different files? Because the 2 upper examples are coming from 2 phishing pages, different phishing pages. The first one from a tech industry kind of phishing page, the second one from a banking phishing page, different, not related whatsoever. The 2 lower ones, the right one is a malware dropper. On the left, you can see Magecart JavaScript being obfuscated, meaning different threat, different code that was originally created, right? No relation, no threat actors are related, but there is something that related to those things. And as I mentioned, there is some pattern here that is repetitive. And that's the pattern here. So you see an anonymous function that get 2 variables, and in that function you have a variable that contains a function trying into that. And that function has a while with a decreasing on an integer value. And then there's some pushing and shifting, meaning there's some manipulation on a payload as part of that function. And that function is actually representing some functionality for a JavaScript obfuscator or JavaScript packer. And that functionality might look a bit different, right? As we can see on those 4 different examples. But the functionality and the structure of that functionality is repetitive. And that actually led me to say, hey, so if there is a structure, right, I cannot do detection of that function by using hash values or text because it's constantly changing. But if there is structure, maybe I can detect that structure in a way. And in order to do that, I was moving into a solution space where I created some sort of a proof of concept. And in that proof of concept, I was using a parsing for JavaScript named AST, which is abstract symmetric tree. And that kind of, ability to take a JavaScript and represent it as a JSON file kind of format, as you can see on your right, with a really, really structured way, with the ability to say, here is the JavaScript functionality being translated to a structure that we know the values and the attributes of that structure. And when I had that structure, right, with that JSON kind of structure, I was able to say, hey, so I can run on that structure and try to pull up some of those indications and some of those metadata of that JavaScript functionality being executed, and just ask the relevant question on that and be able to detect the structure of that. And once I know that that structure is unique, in a way, I created a signature for that kind of functionality, for that obfuscation functionality. And if I will be able to prove that that functionality is unique to that packer, I created a really unique and genuine signature. So that was the technique I was using. I implemented that as a proof of concept and started to say, hey, so now it's the time for me to validate it. How can I take that tool that I created as part of my research and try to validate that against different data sets to be able to say, hey, the concept that I suggested is really working, right? It's not just a theory, it's something that in practice can work. And in order to do that, I was doing some, first step was to try to figure out, a different packers that I want to map and create signature, those structure-based signature for those packers. And I have 5 different packers that I was able to find. The first 2, and we'll go over that really quickly. It's not the really main issue here today. The first 2 ones are really simple kind of obfuscators that are doing they're not new ones, and they're doing a lot of those kind of obfuscation out there. The third and fourth and the fifth, we will go over them quickly, are doing a very repetitive and a well-known kind of obfuscation functionality, which is to take a payload and do some manipulation on that payload, whether that to split that payload or to encrypt that payload. And then the obfuscator code or obfuscating or deobfuscating code will run on that payload, will do the deobfuscating of that, creating the original code that needs to be executed. And that code will be executed once being rendered, and the functionality of the malicious functionality for that JavaScript will be executed, right? That's the basic concept of that. So you see the Cactus on the third one, and you can see the fourth and the fifth one, the packer and the shift push one, right? The fifth one is the one that we saw before. The fourth one, as you can see, I call it packer, and we will talk about the reason why I call it packer, and we'll see some example of that later on, right? So I have five different packers that I was able to create structure-based signature for those packers, and I was saying, hey, that's time to evaluate that. So let's see how I evaluated it, right? You can see on the left side the 5 different packers, and we can start to see some data sets. So the first data set which was a bit dirty, but it was good enough for the beginning of the research, was a phishing database with over 100,000 different pages, and I evaluated those different packers and the signature, the pattern-based signature that I created for that packer. I was able to see detection, which is a good thing, right? That means that I'm on the right track. And then I was doing more validation with a much more precise and much more quality kind of data set, which I labeled as malware. It had different samples, not just malware, but it had some crypto mining, JavaScript there, it has a bit phishing pages over there, but it was really quality one, really labeled and really good one. And I was able to see detection as well, which is a really great thing, right? I'm doing something new. I'm detecting things that I had some issues with detecting before because, right, as I mentioned, obfuscation create a lot of challenges when you use really traditional kind of detection techniques such as text-based and hash-based. And from my point of view and my objective to be able to detect those kind of examples without, those kind of techniques, that was the new kind of detection that I have. Now, first 2 data sets are classified as malicious. The second 2 data sets that I was using, Alexa and some random data set, are data sets that represent something that I would assume is benign, right? Going to Alexa top 18,000 most popular website, go over those websites and try to figure out if JavaScript obfuscation techniques are being used on those pages. That's give me the ability to know which really happened on the benign side of data. And I was able to see some detection there, and that's interesting, right? And we'll cover that. So let's start with the numbers, right? Which is detection rate. So you can see the phishing is 2.1, which, as I mentioned, it's a bit dirty kind of data set, not clean enough, not curated enough, but detection as well. When you go to the malware data set, you can see 26% of that data set was using obfuscation techniques. Only those 5 packers, right? We might have more. And that's an amazing number. That number told me that, obfuscation, JavaScript obfuscation has become a really, trivial kind of techniques being used in the wild to create much more challenges for us from a defensive point of view. It became a mainstream in that sense. And that's something that we definitely need to address. Now, when we look into the Alexa and the random data set, we can see that the detection rate is 0.5, which is low, but it's not 0, meaning JavaScript obfuscation is being used out there for benign website. Why do I know that they are benign? Because I was going over those examples, I was going over those detections, and it was clear to me, and I was, validated that it's not a malicious website or malicious content or malicious code that got into those websites. It was benign and legit code being obfuscated, which is an important thing to say in that context. So inside, JavaScript obfuscation detection is accurate, right? The malicious being detected as obfuscated, which makes sense. The Alexa and the random as well. I was going over those examples. I was not having we created a technique that profile a JavaScript packer, right? And by doing a lot of validation, what I was able to say is that all the things that I detected are actually that signature for those packers and not something else. Meaning it's not something that looks very similar to the obfuscation techniques that I create signature for them, and as a result of that, we might define that as false positive. It was accurate detection because it was an obfuscator that is being detected. Hope that makes sense. Detection, over 4,000 new phishing and malware domains that were detected, right? Again, going back to my objectives, it's to introduce techniques that will help us detect. And those 4K is the new kind of detection that I didn't have before, which means I'm on the right track. I'm doing some value creation by doing that kind of detection. Some of the packages that we're able to see are associated with malicious activity, right? They had, most of their usage we're seeing on data that was classified as malicious and not on data that was classified as benign. Meaning, if I will be able to detect those kind of techniques being used in the wild with high certainty, I would be able to say that that kind of activity is malicious, right? It's a statistical kind of decision. Some benign website can use that techniques, but data show that in most cases it's malicious. Therefore, I can conclude that kind of conclusion, statistical conclusion. And what we learn here, which is a really, really important insight, is that obfuscation doesn't equal to malicious. Meaning, when we detect something that is obfuscated, it's not malicious by default. And therefore, there are two questions that come to mind that need to be addressed, and we'll try to address them from this point forward, which are, first one, so we saw benign website using obfuscation. What's the reason for that? Why should a benign website do security by obscurity and obfuscate some of the content that he has? We'll try to address that question. The second question is, so we know that obfuscation doesn't equal to malicious. Can we introduce a technique, right, an approach that will enable us to say, hey, so let's assume that now we know to detect that something is obfuscated. It's not an assumption. We show that we have a technique to do that. Now, can we differentiate between something that is obfuscated and it's malicious versus something that is obfuscated, which is benign? That's something that we'll need to address, and that's technique that I will hopefully introduce in the next few slides. Moving forward, so the first question, right, was what are the use cases in benign website that we see obfuscation into them? So few use cases, the most relevant one or the most reused one. Email addresses masking, don't ask me why, but some websites, I can understand why. If you want to avoid some scanners or scanners that are not rendering the page, to go over your pages and collect email addresses and reuse them. If you do some obfuscation, you will make their life much harder. Therefore, the chance that they will harvest those email addresses is lower. Again, it's not impossible to do rendering for the page and collect that kind of information. Cookie client-side functionality, I don't want to try to explain that. That's not really good practices, but some obfuscation is being done around that areas to try to do, again, security by obscurity and try to hide some of the functionality of the JavaScript functionality being done on the browser and doing some manipulation on cookies. Third-party scripts, this is the most popular one. Advertising services, translation services that actually are third-party services that some websites are integrating into their websites will be obfuscated by those third-party providers. So in a sense, we can see a lot of those websites using the same services, meaning in many cases using the same code being obfuscated, and we'll talk about the meaning of that same code being obfuscated in the context of some of the techniques that we have to introduce. But that's something that we're able to see heavily being used. And the last, and definitely something that I don't want to try to explain, but a lot of adult content websites are using obfuscation techniques, probably for their own reasons. Again, showing the data, don't want to try to understand that. Cool. So we talked about the first question that we have about what's the reason being obfuscated. Let's talk about the second question that we had in mind, which is how can we differentiate between something that is obfuscated as malicious versus benign? And we'll offer a solution that has two parts. The first one will address false positive. The second one will address true positive. The false positive will say, hey, let's try to take the benign data set that we haven't tried to figure out what we can do in order to in a way whitelist some of the things that we see there. The second approach will say, hey, we have files and let's use a machine learning approach for classifying those files as malicious, right? So these are the two approaches. Let's start from the beginning for the first one. False positives. So think about it like that. You can see here a relationship graph on the screen where you can see the two main gray circle, Alexa and Random, representing those two data sets. Each one of them is being connected to an orange kind of circles representing hash value of scripts that we were able to see associated with those websites and actually being obfuscated. Those orange circles are actually connected to domain that we were able to see using that hash for those scripts. So in other words, let's go back to the third-party example. Some third-party service is having some code that you need to add to your website. He will do obfuscation for that code. It's the same code, it's the same obfuscation, it's the same hash value to that file. If that file is being used by many different domains out there, popular domains, we can go and say, hey, that hash value for a script that's being used like that is a benign one. It doesn't mean it's malicious. And as a result of that, we can eliminate a lot of the noise that might come up from us detecting some obfuscated code being associated with benign websites, right? And, in that sense, remove a lot of the false positive that we might have. So that's the technique that we can take to mitigate and try to make it much more clearer. Using that on the data set that we had, I was able to eliminate 20% of the problem, right? It's not a huge number, but it's a beginning, right? If I had much more data, much larger data sets for the benign websites, obviously those numbers will go up. But that's a technique that will enable us to solve some of the problem, right? First step, right? False positives. Second step, true positives. And the approach is machine learning, right? And I will do that very simplistic. I will not get into details. It's not about the machine learning techniques and whether I use the right one or the wrong one. I'm not a machine learning expert. I know something about machine learning, but it's not why I'm here. I'm here to show an approach or a technique that might be used. Obviously, that technique can be refined and have much better representation for that. So let's try to, from the beginning, try to better understand what we're seeing. So this is the file, this is an obfuscated file, the same one that we saw at the beginning, right? And you can see it's not really readable, but each file, you can look at that file as something, as an object that has all kind of attributes. And we can look into those attributes or features and try to collect those features. So for example, if you have an array in that file, counting the amount of elements of that array is a feature. Looking into those elements and having the length of those elements can also be a feature. Looking on different characters that being used in those elements can also be a feature, right? These are those kind of features. Different features could be identifiers, right? Identifier would be a function name or variable names or stuff like that, right? So looking on those and saying, hey, how many identifiers start with _0x, as you can see in the example here. It's a well-known technique being used to create an obfuscated code that is not readable. How many identifier in total, unique identifier in total, we can see on a given page. These are kind of featured, and we'll use some of those features, only 3 of those features, to try to see how we can create a module that will enable us to do a better detection, a better classification of data sets known to be malicious or benign based on what we are seeing, right? So let's put it on a graph, right? And I took a portion of the data set that we have. I took those files that were identified as being related to push shift packer, one of the packers that we have. It's important to say that it's the context of each packer and the features of that packer and how they are being used. And I will try to show that with 2 features. The left one, right, what you can see on the left is the unique identifier, meaning the number of unique identifiers that we were able to see on the files that we know that were well, obfuscated by push shift packer. And on the right side, you can see number of elements in array, right? Again, collected from those files. And we have three data sets, two of them related to benign, which is random and Alexa, and the green one, right, the blue and the red are the random and Alexa, and the green one is something that was classified as part of the malware data set. So only by looking on this graph, we can see something very clear, that there are different classifications, there are different groups here that will enable us to say, hey, if a given feature has a value, whatever that value is, that means that that group is associated with a behavior that is more relevant to malware rather than to something which is more benign, meaning random, well, the random dataset or Alexa, right? So we already see three groups just by looking at that. But more to that, if we will take the group on the center that is close to zeros, right? And we'll focus on that, what we were able to see is that even on that group, if we will do much closer look into that, we can see that features make sense, meaning we have the ability to create some sort of a decision tree of those features and some values for those features that will enable us to say on a given obfuscated file whether that file is benign or malicious. And this is what I created, right? A decision tree, as you can see in front of you. And we'll not get too much into details on how that decision tree was created and what's the meaning of each node of that tree. But just as an example, if we take the most right path of that tree, and we have, as I mentioned, three features here. The first one is the number of identifier, meaning function name, variable names. They start with _0x. The second feature, number of elements in array. And the third feature, the number of unique identifier. Only by taking those three features, we were able to identify over 50% of the data set as being classified as malicious. Meaning we solve 50% of the problem only on that path of the tree, saying when a given file has more than 20 identifiers starting with _0x and more than 17 elements in an array and more than 92 unique identifier, then with a very high certainty in our case, in this case of this experiment, that file represents something that is classified as malicious, right? This is, well, machine learning in a very simple and simplistic kind of representation. Hopefully that makes sense. So we had 4 questions, right? We have at the beginning of the research or the beginning of my presentation, we talked about the why and the how, right? And we addressed that. We tried to show some numbers in the wild and what those numbers represent, and we were able to see that as well, right? 96% of the malware data set were already classified as being obfuscated. That's an amazing number, right? We tried to answer the question, does JavaScript obfuscation equal to malicious? And we addressed that as well. And last and definitely not least, we were able to see techniques that will enable us to say, hey, here is a given file. We know how to identify that being obfuscated. And more to that, we have the ability to show if that file is malicious or not in a machine learning statistical way, right? Few of my next steps as part of this research, right? I want to release the code for that, for this project. I'm working on that, hopefully in the next few months. Adding signature for additional package, right? I covered 5. I would like to add more. Refine some of the data sets that I'm using to be able to show better results, right? I talked about the phishing, which is a bit data set that is a flaky one. Add more features into the machine learning model and explore the ability to algorithmically look into obfuscated files and create those signatures that I was creating. I created them manually, right? I was going over those files and was looking for some, functionality that is associated with obfuscation, and I was able to see that functionality is always being used as part of that packer, and I was able to a signature for that. Doing that algorithmically or automatically will make much more sense and create much more accurate results. So I promised to talk about the package, right? That obfuscation functionality that we saw in previous slides, because the name of the presentation is all about the package, right? And some of you might ask yourself, and I don't want you to lose sleeping hours over that, right? Why did it shows Packers with the dashes, right? So the reason for that, because I saw that given function, and the variables for that function are PACKER, which is Packer, right? So that's the reason for that. But wait, so part of the techniques that I was suggesting is to avoid looking into those kind of variables name, looking into the structure, right? Variable name can change. Well, I was doing a right decision on that, because as I was continuing my research, I was able to see some example for the same functionality, but now being used with the variable name PACKED, right? Because instead of R at the end, right? I was making a nice decision, but it's not the end for that, because I was able to see another functionality for that, using even more obfuscated kind of one, not readable kind of version of that, with the underscore x1765x1, right? Those values, which makes much more sense in my ability to choose not to use those kind of variables name as part of the signature for the things that I was doing. And as a result of that, I was saying to myself, hey, so maybe I should change the name of my presentation. It's all about the underscore 0x167. Okay, so that was my joke for today. Hopefully it was a funny one. It was a geeky kind of funny one. At this point of time, I want to thank you very much. If you have any question, if you have any concern, don't be afraid to reach out to me. I'm here to answer some of your questions. Thank you.